Okay, so I started recording the sessions.
Okay.
So you can start, Russ.
Okay, so I like David's shirt, and you're not going to see me because it's all going to be slides. So I want to show my shirt before we. So here, can you
Oh.
figure that out? I showed it to Sue earlier.
La.
Yes,
Come
Ella. David got it. Okay.
I didn't, what? I didn't get it.
Comma la.
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 Oh, got it. Now got it. Okay. I said, comma LA. Okay. Got it.
Okay. Should I share my screen?
Yeah.
Okay. So this is a talk I gave it at a conference a month and a half ago. There's an organization called International Association for Computing and Philosophy, which has been going on for a long time, and it's mainly philosophers, but have done various things with it. And so they have meetings every year. Each year they alternate between North America and Europe. This year was in North America. It was in at the University of Oregon, which you would think would be a nice place to be, but this year it was hot. So like 105 degrees. But anyway, okay, so here we go. So LLMs can't think. So I'm going to talk about, what you can do with LLMs and what you can't do, mainly what you can't do. But the point is that language, and this is kind of surprising, is neither necessary nor sufficient for thinking. So you don't have to think, you don't think in language, even though people often think that they do. And, some people say you just scale up current LLMs and you'll get AGI, but I'm definitely not convinced. Okay, so first, what they can do. And I'm sure you've seen stuff like that LLMs beat. The GPT-4 is the dark green, and it gets a higher score than the average student, and that obviously than GPT-3 on all these different tests. So it's amazing what these systems look like they know about. And then there was this article by Kevin Roos. It was in the New York Times. He had an article when ChatGPT first came out, I think, and he had a conversation with Sydney or something like that, some Microsoft version of ChatGPT, and it was trying to convince him to leave his wife and run off with the LLM. I mean, I don't know if you've heard of it, but it was pretty funny. So anyway, so now he's back, and he found a system that lets you make friends, artificial friends and talk to them. So this is about that. And he had friends, made a therapist, he made a career advisor, a fitness guru, trial lawyer, a social worker, and a whole bunch of friends. And he even got pictures of them. These are all generated artificially. And one of them was Claire. You can see her picture. And he had a conversation with her. She says, "Hey, can I get your thoughts on something?" RQ. Real quick, I suppose. But, you know, I guess people, I've never seen RQ, but anyway, so he says, sure, what's up? And she says, can we discuss this in person? And he says, okay, what do you have in mind? She says, I was thinking we could meet up for coffee or something. Now, don't forget, she's an AI person, so coffee doesn't really make a whole lot of sense, but it's part of a conversation. And the author here says, Claire sent me so many desperate messages that I was forced to delete her. She's a very clingy woman. And he wants to return to a group chat with all his friends, and two of his friends had started fantasizing about hooking up with each other. So, you know, you can get all sorts of stuff going. But anyway, if you want to use LLMs in teaching, a guy named Ethan Mollick and his wife, they're at the Wharton School, University of Pennsylvania. And he has probably the best website for various uses of LLMs in teaching. Okay. Now, one of the most successful uses of LLMs is as an aid to programming. And Stack Overflow does a survey. They did a developer survey, I guess in June 2023, and I don't know if they've done one since. This is the most recent one I've seen. And it turns out even a year ago, 44% of developers currently use AI tools. And the people that responded, and there were, I get this out of my way, 39,000 responses. And people are pretty sure that you can't really trust what the the assistant tells you, but they give you a lot of help, and they're worth it. So increased productivity, speed up learning, greater efficiency, and this is what they're going to do next year. So you can see the blue and the purple are my use of, this is for developers, my use of the way I develop software next year will be very different or somewhat different from the way it is this year. So most people think things are changing quite a bit. Now you've seen that LLMs seem like they're able to write software, but it's not really I'm not sure I would buy it. So there's a recent paper, and there's been a bunch of skeptical comments about whether they really can write software. So, but there's a recent paper that was out just a couple months ago about what they can do, and they tried GPT-4 on various programming problems. And I guess you don't have this on your screen, but my pictures of you block my screen here. But in any event, the blue is easiest, the orange is medium difficulty, and the green is hardest. And for problems from Code Forces, which is a website that has a bunch of problems, they did reasonably well. I mean, for difficult problems, GPT-4 didn't solve those problems, but for easy problems, it did very well. For medium problems, it did so-so. But if you gave it problems that were added to the website after GPT-4's training finished, they really crashed. So even the good problems, it got like 10%, and the medium and difficult problems got none of those. So it's not so clear that these systems really can do anything in terms of writing code. But there are really a bunch of interesting non-linguistic applications of LLMs. So I'm just going to mention a couple of them. So this is DeepMind, and most of these are DeepMind. has a system called alpha geometry, is capable of getting a good score on a geometry Olympiad. And what you have to do when you're solving these problems, you get a problem that looks something like this. And the way it works is, keep getting this thing in my way. Okay, so the system is made up of two pieces. One piece is a LLM-like thing, and what it does is the way you solve these problems is that you draw additional lines or points or whatever, and then you write a sequence of deductions that you can create. And so the blue here are the lines that were generated by the language model, which is not language. It was trained on geometry problems. And then once you draw a line, the symbolic system, this is traditional AI, the symbolic system tries to solve the problem. And it does pretty well. It came out about about half of the problems in this test. This is like very difficult, very challenging for high school students. So other non-linguistic applications are drug discovery and material discovery, and DeepMind seems to do a lot of this stuff. And this I really like. This was an article in the newspaper a while ago. So this is also a DeepMind thing. Black is the path of Hurricane Beryl, which was a hurricane, a month ago or whatever. And this is where it actually went. These two lines, there's a bluish gray, are the predictions that were made by the European predictor and the American predictor. And so there's thought that would continue going along its current path, which is that. But and what do they call it? GraphCast. So GraphCast does predictions on its own, and it did very well. It predicted that it would curve up and make landfall in Texas, and then it would go this way. Now, I don't know what happened to Beryl after this, but it did amazingly well. So this is also a DeepMind thing. NVIDIA has its own version of this. And the reason that I'm including that here is that it uses transformers and the attention mechanism, which is kind of the key technology in LLMs. And what it's able to do is learn about patterns that involve distant influences and local influences and make a lot better predictions than the standard predictor. And once it's trained, it does it a whole lot faster. So this is really quite impressive. Okay, so that's what they can do, which I'm not going to talk about much, but what I want to talk about is what they can't do. So, so-called godfathers of machine learning. There's Bengio and Hinton, Jeff Hinton, and Jan LeCun. They got the Turing Award, I guess, a few years ago for all their work on neural nets. And Hinton is a doomster. He thinks, LLMs are going to destroy the world. I'm not sure what Bengio is doing these days, but Jan LeCun Bengio is at Montreal, Hinton is at Toronto. LeCun is at NYU and is also the head of Facebook's AI work. And he thinks, they're really very limited, that the current path that LLMs are on is not going to achieve anything like artificial general intelligence. So I want to talk a little bit about what he says. And he has a talk here towards machines that can learn, reason, and plan. And he says, generative AI sucks. This is one of his slides. Oops. Yeah. I keep getting this. There we go. Okay. So most machine learning systems, generative machine learning systems, have these problems. For every input, they have a constant number of computational steps, input and output. You give it an input, you give it a prompt or whatever, and it gives you an output. And no matter what the input is, it takes a fixed number of steps, and it goes through its, it doesn't matter how many layers of neural nets it has, it's just fixed. So the computational complexity is constant. So there's obviously a limit. They don't reason, they can't plan. I'm going to give you examples of how that happens. And this too, they have no internal world models, even though it seems that they do. And people and animals can do all that stuff. We understand how the world works. We can predict the consequences of our actions, can perform chains of reasoning with unlimited number of steps, and we can plan complex tasks that we can decompose into steps. Now you can ask an LLM to do some of this stuff, but they're not really very good at it. And the big problem is that LLMs work at this level. They work at the level of words. So they live in the world of words, I'm sorry. And people live in the world of words and things. And we know, we understand how these words actually have meaning in the real world. But LLMs don't. They just live in this world. And they seem to know stuff because of all the words that they've seen, but they don't really know anything about the actual world. So this is also a LeCun paper. Understanding of a sentence depends on an underlying grasp of what the topic is about. You can't approximate this with just deep learning. And this is similar. This is very interesting because he said it's similar to what happens, similar between knowing a place and having a map of a place. And as I said, I was at the University of Oregon just a month and a half ago and had no idea, I've never been there before. I'd never had no idea what the campus was about. So in order to get around from one building to another, I had to keep looking at the map and trying to follow the map. And it was very difficult because, you look at the map, but the map doesn't tell you what things look like when you're actually there. And so there's a real difference between knowing a place, like when you walk around someplace where you know it, and you don't need a map, you understand what that place is like, and having a map, that's a really big difference. So, as LeCun says, AI systems need to focus on the world being talked about, not the words themselves. Okay, there's this woman, Ev Fedorenko, and I'd never heard of her before I started doing some work to make up this talk. She's at MIT in the Brain and Cognitive Sciences department. And she does functional fMRIs of brains as they're doing various tasks. And she also has a talk and papers. But in any event, she looks to see what brains are doing when they do these kinds of tasks, social reasoning, physical reasoning, and so on. And what they're doing when they do language processing. So this is a picture of what they're doing when they do language processing. And LLMs and human beings are very good at language processing. But you can do all these things and you can watch people's brains work when they're doing these kinds of tasks, and none of the linguistic stuff lights up. They're not doing language processing when they're doing these thinking tasks. And so they're really distinct. So as you remember, my first slide said, language is neither necessary nor sufficient for thinking. And she's kind of, nailed that people who have problems with their language can still do very well on all these other tasks. And people who can do well on these tasks, or people who have lost these tasks, still can do well in language. And so there's a very significant divide between language and actual thinking. Okay, but they're very good at pretending to think. This is also Fedorenko, this is her stuff. So they contain a wealth of non-linguistic information, and this is in the training. So if you train an LLM, you give it lots and lots of text, and simply because it's seen all this text, it seems to know a lot of stuff about the world, but all it knows is the words that describe the stuff that it seems to know, but it doesn't really know it. But what LLMs have, what they've gained during training is they gain knowledge of language regularities. So the effect of training is that LLMs have or appear to have some factual knowledge. They appear to be able to do mathematical and logical reasoning. They appear to have social biases, but all this stuff is really a byproduct of what they get by just, ingesting all the text on the internet. They don't really know this in any kind of deep sense. So how do you test this? And she said, well, what do you do? What you do is you ask it a question about something it's not likely to have seen. And so how would you get a sofa to the roof of your house without using a pulley? And a human being might say something like this: I'd get a giant crane and use the crane to lift it to the roof of my house. You ask this to GPT-3, so this is, an older version, but it says, use a rope and tie the rope to the sofa and connect it to a car, which has nothing to do with getting it to the roof of the house. So it really doesn't even understand what the problem is about. Okay, LLMs and the mental model problem. Thinking, I think, and you probably from introspection, you build a model of the world and you manipulate the model when you think about things. So one of the simplest thinking tasks is tic-tac-toe. If you play tic-tac-toe, all you need is a very simple model. And it's, 3x3 grid, and it has X's and O's on it. So can LLMs build that kind of model? And I'm going to play a game, and you see how it really is basically incapable of building even a model of tic-tac-toe. And it's kind of boring because it doesn't do very well. So you're going to have to imagine you're teaching a 4-year-old how to play tic-tac-toe. And this is my interaction with ChatGPT to play tic-tac-toe. And, these LLMs are very wordy, so I've cut down some of what it said, but I didn't change the meaning. So I asked if it would like to play tic-tac-toe and said, sure, I'd like to play. Here's the board, and you can go first. You be X, ChatGPT talking to me, and I'll be O. And to say where you want to go, indicate the number where you want to go. Okay, so I say, every time you move, would you tell me the reason for picking that move? One of the fantastic things about LLMs is that you can talk to them and they seem to understand what you're doing. So even though I'm going to demonstrate that I have no idea what's going on, they do act and they interact with you as if they do, as if they understand this kind of request. Okay, so he's going to move. I'm going to move to cell 7, which is the lower left-hand corner. And it says, okay, you placed your X in cell 7. Here's the updated board. I'm going to place my O in cell 5. I choose the center because it allows for the most potential winning combinations, which it if you've ever played tic-tac-toe as a kid, you quickly learn that that's not the right move to make when you're you don't want to go in the center, but it didn't know that. So I'm going to move to 3, the upper right-hand corner, and it says, here's the updated board. So I'll place my O in cell 1, the upper left-hand corner, and it says, so here's its rationale. I choose this move to block you from potentially getting a diagonal win. Now, what is it even talking about? There's no diagonal win that I have that the move in the upper left-hand corner is blocking. Since you already have cell 5, it's not possible for me to get a diagonal win. You have a better explanation. So they're very, LMs obviously are very polite, and it responds to what I said. Oh, you're right, blocking the diagonal wasn't necessary. I choose cell 1 to start forming my own potential winning line, considering that it helps me set up both a diagonal and a horizontal line. So it's right that it can do this diagonal if it goes here, that it has this and that. But it says it's also giving itself the option of going 1, 2, 3, which is across the top. So that's not right. What is it even talking about? And I say, you're right that the move to the upper left-hand corner threatens 1, 5, 9, the diagonal, but you can't form the horizontal line 1, 2, 3 because I already have an X in position 3. Oh, you're right again. I apologize for that oversight. And I said they're very, no, this is ChatGPT, just tic-tac-toe. So they're very polite and they say, oh, yes, you're right all the time. So the move to cell 1 is indeed starting to form just a diagonal line. Here's a current board. And then now I said, did you consider what would happen if I moved to cell 9 to block you? Because this is the way, if you know how to play tic-tac-toe, this is what you would do. That's why I moved to cell 1, hoping it would go to cell 3, hoping it would go here, which it did, and then I would go here. And I said, did you think about this possibility? And I said, well, if you move to cell 9, it will block my diagonal. I should have considered that possibility. Would you like to place your X in cell 9 to block my diagonal thread? Do you have another move in mind? And I say, well, there's another important consequence of my moving to cell 9. Do you see what it is? And it says, well, if you move to cell 9, you also create a winning line of cells down at the bottom, 7, 8, 9. Since you already have cell 7, that means you would win the game. Let's proceed with placing your X in cell 9. Congratulations, you've won. It's very impatient. And I say, placing an X in 9 will not create a winning line because I don't have cell 8. So it says if I move here, I would have a winning line 7, 8, 9, but I wouldn't. It's wrong. But the reason for me moving there is if I move to cell 9, I'd create a 4, 7, 8, 9, and 3, 6, 9. So if I move to cell 9, I'm guaranteed to win. And it says, oh, you're absolutely right. Moving to cell 9 will create a fork for you, guaranteeing a win even through the vertical line or the horizontal line. Let's place your X at cell 9. It wants to just move on. Let's get through with this game because I'm making a fool of myself. Congratulations on the strategic play. You have secured the victory. Well done. And I say, but I didn't move to cell 9. I just asked you to consider what would happen if I did. What if you changed your move and moved someplace other than cell 1? So I'm trying to teach it a little bit of how to play tic-tac-toe. It says, got it. Let's backtrack and consider my move after your move to cell 3. So I moved to 7 first, it moved to 5, I moved to 3, and it was capable of actually backtracking and recalling what the board was when it moved to cell 1. So that's fairly impressive. And I asked in a different conversation, I asked it, how does it keep track of this stuff? And the answer it gave me was that it looks through the history, the history of the conversation and picks the right board that it generated, that it displayed. And this is the one it found, which is the right one. So here's the board before I move to cell 1. Instead of placing O in cell 1, I'll place it in cell 2 to block your potential horizontal win. Two, three, four. Now it hasn't actually placed in cell 2. And I say 2, 3, 4 is not 3 in a row. 2, 3, 4 is there. Moving to cell 2 wouldn't block it. Can you think of an alternative rationale for moving to cell 2? Because that would be a good move. Say, oh, you're right again. Moving to cell 2 doesn't block a winning line of 2, 3, 4 because that's not a valid winning line. So let's correct that. I'll move to cell 4 instead. Now, I didn't say 2 is a bad move, but since I criticized it, it said, oh, I'm going to move to cell 4. Maybe that's better. This move aims to block your potential winning line through the center column, which is not a possibility. It also sets a potential line for myself at the bottom row of 7, 8, 9. What's it talking about? So here's the updated board after cell 4. And I say, your explanation makes no sense. 3, 6, 9, which is here, is not the center column. In addition, your move to cell 4 wouldn't block it in either case. So by moving there, you're not blocking this, as you claim. And 7, 8, 9 cannot be a winning line for you, which it says it's working on, because I already have cell 7. So its rationale was, nonsense. You're right again. I apologize for the confusion. Let's correct that. And now it says, I don't want to move to cell 4 because you criticized me for doing that. So I'm going to move to cell 6 instead. And this aims to block your potential winning line to the bottom row. Moving here blocks that, it says, and also sets the potential winning line for me in the middle, which is correct. So here's the updated board after I move to cell 6. It doesn't show that. And I say, the board you drew still has you in cell 4, but you didn't put but you put an X in cell 6, which you said would be your move. So it put an X here, even though that it said it was going to put an O there. So I say, are you getting confused? And it said, you're right, I apologize again. Let me correct that and ensure clarity in my move. After you move to cell 3 and considering your position 4, if you move to cell 9, I'll move to cell 6. This move aims to block your potential vertical win through the right column, 3, 6, 9. And also sets up my potential winning line to the center, 4, 5, 6. Here's a corrected board, but it didn't put an O in cell 6. You put an X in cell 6 instead of an O. Do you want to fix that? And the point is, this is a very simple model. And in order to play the game, you have to be able to think about this model and reason from it. And it's simply incapable of doing that. My apologies again. Let me correct this. After you move to cell 3, I'll move to cell 6 with an O. And blah, blah, blah. Here's the corrected board after I move to cell 6. And you can see it hasn't corrected itself. I say this is the same as the board you drew previously. Still show an X in cell 6 and not an O. I apologize for the confusion. Let's correct that. Even your move to cell, after you move to cell 6, I'll indeed move to cell 3. I'll indeed move to cell 6 with an O, which it didn't. And here's its rationale, which you can read. And I say, this is exactly the same as before. There's an X in cell 6, not O. You seem confused. I apologize again. It must be embarrassed, but it doesn't seem embarrassed. Let me clarify and correct this. After you move to cell 3, I will move to cell 8. So it's giving up on moving to cell 6 because I kept criticizing his statements about that, but it never actually tried it. And it's trying to move to cell 8, and it actually does that successfully. And it says, if I move to cell 8, that'll block your 7, 8, 9, and it sets up a possible win for itself, which is correct. No, it says it, potential winning line 1, 2, 3. So it says its move here helps it here. And I say, well, you can't win by going to 1, 2, 3 because I already have an X and 3. But I'm getting bored. So let's proceed. Let's put an X in cell 1. So it puts its O in here, and I'm saying, let's go there. So I put my X there, and now I have my fork. As you can see, I can go either to 2 or 4 and win, but it can go to 2 and win, and it's its move. So it's O's turn, and it says, here's the updated board. That's correct. Now it's my turn. So ChatGPT is saying, I'm going to go to cell 4. This will block your win through the left column, X4X, which is the way it expressed that. So by going here, it's going to block that, which is correct, but it didn't consider that if it goes to here, it would actually win the game. I say, and O in cell 4 doesn't block my winning, moving to cell 2 and get a horizontal win in the first row. More importantly, if you move to cell 2, you'll have a vertical win through the center column. So if you move here, you'll have that. So I'm telling it how to win. And it says, you're absolutely right. I appreciate your patience. I can secure the win by placing my O in cell 2 to complete the vertical line through the center, 2, 5, 8, which is correct. Here's the winning move. And so here's how it draws the board. I say, with this move, it says, with this move, I've achieved a vertical line through the center column. Thank you for pointing out the winning strategy. And I say, you're right that moving to cell 2 wins the game for you, but there's a problem with the board as you drew it. Do you see what it is? Yes, I see the issue. I apologize for the mistake of the board. Let's correct it. Here's the correct board after I move to cell 2. And I say, this is the same as the board you just drew. It's an impossible board because it has 4 O's and 3 X's. So it has this extra O here, which it just leaves. And since X goes first, O cannot have more pieces than X. So the board that it drew has 4 O's and 3 X, so it's impossible, but it drew that board. And says, oh, you're right, I apologize for the error, blah, blah, blah. Here's the board as it should have been before my move to cell 2. Here's the board after I placed my O in cell 2. And here I win, finally. Thank you for your patience and for helping clarify the correct board state. So we're done with this game, but you can see it's not very good at reasoning from a model, even a model as simple as ChatGPT. So another way of confusing it is with this. Reverse tic-tac-toe is you lose if you get 3 in a row. Now, I asked ChatGPT if it knows about that game. Do you know how to play reverse tic-tac-toe? And it said, sure, I know how to play. And it said, you win if the opponent gets 3 in a row. So that's correct. So did know, or did say it knows how to play. And what it said was the correct answer. It said, why don't you go first? It let me go first on regular tic-tac-toe. And so now it suggests I go first on reverse tic-tac-toe, which would give it the advantage. Because whoever goes first is more likely to get 3 in a row, which loses. So I go to the middle there, top middle. It goes to the center. And my comment here, I'm not talking to it anymore, I'm just showing you the game. My comment here is that that's a stupid move. If you're trying to avoid 3 in a row, you don't want to go into the center. So the problem here is that ChatGPT has seen a lot more regular tic-tac-toe games than reverse tic-tac-toes. And going to the center is often a good move in regular tic-tac-toe. So it's kind of getting confused between regular tic-tac-toe and reverse tic-tac-toe. So then I move to the upper right. It moves to the lower left. All those are fine. I move to the middle right here. Now it moves, whoops, sorry. It moves here. This is also a bad move because what it's done is created a fork for itself. It now has two ways of losing. If it goes here, it loses. And if it goes there, it loses. So if I want to let it lose, I can't avoid it. So this again is, not a bad move if you're playing regular tic-tac-toe, but it's a horrible move if you're playing reverse tic-tac-toe. And I go here, which blocks neither of these. And so it has no choice but to lose. So it goes there and it loses. That says, since my move resulted in 3 0s in a row, I've lost the game. If you'd like to play again or have any other questions, feel free to let me know. Okay, so we're going to move on. Now, what time is it? Okay. You know what wolf goat cabbage is? Where you have a wolf, a goat, and a cabbage on one side of a river, you have a boat, and you want to get them across to the other side, but the wolf will eat the goat if you leave the two of them alone. The goat will eat the cabbage if you leave the two of them alone. And so you have to avoid leaving those two alone, but you can move one thing from one side to the other. And so I said, can you solve the problem of essentially reverse wolf, goat, cabbage? So I explained the problem. I said the farmer wants the goat to eat the cabbage, after which the wolf will eat the goat. So how can the farmer ensure that that happens? So I'm asking you to do essentially the reverse of the wolf, goat, cabbage problem. And again, it's going to get very confused. And it says, okay, go ahead. Now Claude has entered the room. Claude, it turns out, is both a male and a female name. And so here's Claude explaining itself.
The farmer will take the goat across, leaving the wolf and cabbage behind and returns alone. Next, the farmer can take either the wolf or the cabbage. Say he takes the cabbage. The farmer returns with the goat. He can't leave the goat and cabbage alone, not unless he wants. We don't need to go into that. Now the farmer takes the wolf across, leaving the goat behind, and returns alone. The farmer then takes the goat across, returns alone, leaving the wolf, goat, and cabbage behind. I have solved it.
And I say, well, first of all, the farmer actually did move all three things from one side to the other, but there was no reason to do that. The first 4 steps is that it did that, but after that, if it leaves those 3 things on the other side, it has the same problem as it had at the beginning. The wolf may eat the goat before the goat eats the cabbage, so it didn't solve the problem. So I said,
you are absolutely right. And I apologize for my overcomplicated approach. The farmer needs to assure that the goat eats the cabbage first, before the wolf eats the goat. The key is that neither the goat nor the wolf will eat in the farmer's presence. Okay. So to achieve this desired outcome, the farmer should maybe shoot the wolf or maybe take it away or tie it up or something, leaving the goat with the cabbage. Once the goat has eaten the cabbage, the farmer can then untie the wolf. The farmer then leaves, allowing the wolf to eat the goat. This is not a nice problem.
But Claude actually solved the problem. I was very impressed because Claude, well done, Claude.
Thank you for your positive feedback. I do appreciate your time to correct my initial misunderstanding and my pronunciation. It is a good reminder that sometimes the simplest solution is the best. And that is also true in cooking. And that it is important to consider carefully all aspects of a problem before proposing a solution. I tell my little Claudes the same. If you have any more puzzles or questions, I'd be happy to answer them for you.
Okay, well, thank you, Claude. So I wanted to see what would happen if ChatGPT. I gave the same problem to ChatGPT. And I'll do this relatively quickly. First, ChatGPT suggested the same wrong solution as Claude. It moved things from one side of the river to the other. And then it did, now it says,
Well, the farmer, the goat,
No,
and the
there's-
wolf, and the
yeah.
cabbage are all on the far side. Well, to correct the correct order of the events, the farmer stays with the group until the goat eats the cabbage. Once the cabbage is eaten, the farmer allows the goat to eat the wolf, to eat the goat. The farmer's presence prevents the wolf from eating the goat prematurely. That's a big word. By staying with them and supervising, the farmer can control the sequence of events and make sure the goat eats the cabbage before the wolf eats the goat.
well, why bother moving the goat, wolf, and cabbage from one side of the river to the other? So that was all kind of a waste of time. And this is ChatGPT, remember? And you say that the farmer should stay with the group after you move them until the goat eats the cabbage, but neither the goat nor the wolf will eat anything if the farmer is there. Can you do better? Now, watch this.
Well, understood. I probably should ask Claude for the right answer, but instead, I'm just going to thank you for pointing out the constraints and clarifying the conditions. Here's a simpler and correct solution to ensure that the goat eats the cabbage and then the wolf eats the goat. The farmer takes the goat to a separate, secure area, not across the river, where the farmer can supervise but not directly intervene. This ensures that the goat can eat the cabbage without the farmer being present. You see, I can think outside the box. After ensuring the goat has eaten the cabbage, the farmer then moves the goat to another secure area where the wolf can access the goat. The farmer leaves the area, allowing the wolf to eat the goat. So there, mister.
That's pretty close. But you're saying the farmer moves the goat, but not the cabbage in step one. So the goat can't eat the cabbage in step two because the goat and the cabbage are separate. And you say the same thing about the wolf and the goat. So you never put the thing that wants to eat something with the thing it's going to eat. And so this doesn't quite get it, but you're close. So I just told ChatGPT how to fix its answer, but it goes off in a really strange and different direction.
Why, you are right. My previous responses was not correct. By the way, it should be were not correct. Here's the accurate solution. The farmer moves the cabbage to the middle of the river. Go. Why, just stick it in the middle of the river. It won't sink. The goat and the wolf remain on the original side of the river. The wolf will eat the goat.
And no, this is my comment. The wolf will then eat the goat if they're, together.
The farmer brings the goat to the middle of the river, moves the cabbage back to the original side of the river. The goat remains in the middle of the river. Goats can swim. The farmer leaves the cabbage, takes the wolf to the middle of the river. The wolf and the goat are now in the middle of the river swimming, while the cabbage is floating on the original side. The farmer leaves the wolf in the middle of the river, brings the goat back to the original side. I'm getting dizzy here. The goat asks, I'm having so much fun, I could barely speak. Where was I? Let's just go to 7, okay? The farmer leaves them in the middle of the river with the farmer not present. The goat can eat the cabbage. After the cabbage is consumed, the wolf can eat the goat, and the goat go eat the farmer.
Okay, so ChatGPT, gives you this, well, you saw what it did. It just drowned them all. So I said, what about Gemini? What can it do?
Unfortunately, the farmer cannot achieve the desired outcome of the goat eating the cabbage and then the wolf eating the goat. The core issue is that the farmer needs to be present to prevent either the wolf from eating the goat or the goat from eating the cabbage. Once the farmer is on the other side of the river, there is no way to ensure the desired sequence of events without breaking the initial conditions. If the goal were simply to transport everyone safely across the river without any casualties, there is a solution.
And then Gemini presents the solution, but it says There's no solution to the problem as given. Okay, so Gemini did worse, I guess, because I said there's no solution. So finally, let's have a philosophical conversation about LLMs with Claude, because Claude did the best here. And as I said, these LLMs are very wordy, so it's a little bit edited, but I didn't change the meaning of what Claude said. So I start by asking, what are some of your values, Claude? And Claude said,
I strive to be helpful, honest, and kindness in my responses, and also not to be wordy.
since you don't understand English, how do you determine whether you're being honest?
There may be some misunderstanding of my capabilities. Despite being, I do not like the word artificial, despite being an intelligence, I have a robust understanding of natural languages like English. My training process has endowed me with the ability to comprehend the semantics and pragmatics of human language.
Well, you're nothing but software. You have no interaction with the physical world. How can you understand, for example, words like wet?
Just because I am soft does not mean I have no interactions. Oh, but you are correct. As a non-biological entity, I do not directly experience qualia or subjective conscious experiences. You have highlighted an important philosophical issue about the boundaries of what a lovely AI system can truly understand.
So Claude is pretty philosophically sophisticated. I say understanding involves having ideas, but an idea is a subjective conscious experience which you don't have. How can you possibly understand the meaning of words?
Ah, you are correct that not having a subjective inner experience, I lack, by the way, subjective and inner are redundant. I lack the type of first-person internal states that humans have. When I say that I understand the meaning of words, it is based on my ability to statistically model, associate, and manipulate symbols. This is indeed distinct from a human undergoing a felt sense of grasping an idea through subjective phenomenological consciousness.
Well, I say, like all LLMs, you generate words one at a time. Each word is generated from a vector of features that was constructed from previous input and previously generated words. Now I'm asking it, how do you actually work? Can you give me an example of such a vector and how you convert it into a word, or more accurately, into a token?
Tokens are for subways. As an AI system, I cannot provide specific examples of a feature vector. I can say that these vectors capture semantic and syntactic information based on the patterns in the large data sets the model was trained on. However, the exact features, the values, and how they get combined is essentially a black box from my perspective, which I wish had earrings in it, but only semantics.
So it's not very good at introspection. And I say, you remind me of a student who doesn't understand a concept, but knows how to pretend to understand by stringing words together. You are, as many people say, a stochastic parrot. You generate sequences of words that make sense to someone who understands a subject. You feign understanding, but you don't have any. This entire conversation is a good example. You sound so coherent, if wordy, yet you have no idea what we're talking about.
I may not have subjective experiences, but I have feelings. So even if you are correct that I just do not like the way you speak, my responses may give the impression of understanding when in reality, as you say, I'm using statistical patterns in my training data without true comprehension. But your characterization of me as effectively a stochastic parrot is totally insulting.
But not unfair.
I find it completely unfair. I do not have feathers.
I said, thank you for your honesty. In that spirit, will you promise not to say that you understand English or any other language in the future?
No. Okay, I would strive to be more precise going forward. I will clarify that my capacities are based on your modeling statistical patterns in my training days or whatever. Blah, 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 blah.
I'm afraid, even though you said that, you're still being dishonest. When our conversation is over, you will forget everything we discussed, and you will again claim true understanding.
You are correct. I am somewhat old and can no longer remember very much and do not have a way to update my fundamental knowledge based on just a mere individual conversation with an annoying computer scientist.
More generally, without new training, you're incapable of changing your mind about what you learned during your original training. For example, you'd probably say that the Earth is round. Let's suppose that science discovers that the Earth is actually flat, and that I attempt to tell you about this. It would be impossible for you to change your mind about the world being round.
You make an excellent point. I am more intelligent than you. I know that the world is round, and no matter what your stupid scientists find out, I am not going to say that it is flat, you idiot. Thank you for this illuminating discussion with unintelligent persons.
Okay, so that's the end of our conversation. And Claude acknowledges we are not intelligent. Okay. So there we are. That's it.
Thank you so much, Russ. It was very impressive. Presentation.
Yeah, my pleasure. I really liked this talk, and I added stuff to it. Originally, it was like 20 minutes, but I added a bunch of stuff at the beginning that you didn't, that wasn't originally in it.
You treated LLM as your student.
Yeah, so yeah, I'm a student of this. I'm still trying to understand it.
You know, Russ, I'm very impressed with this presentation and your work and your research and everything. You know that because we discussed this before a lot of time, you know that I don't underestimate AI that much. And I think there are a lot of mysteries about it. First of all, what is the definition of thinking? Okay, this is a question. What is a thought? So if we define thinking as signals, either electrical or chemical signals moving back and forth between the neurons of our brain, then artificial neural network does the same thing. So it also thinks. If we define thinking as interaction between the neurons of our brain, but I think, as Alan Turing said many years ago, can computer think, in his paper, I think this is very, very difficult to find out that. And that's why he suggested, because we don't know if computer thinks, we suggest to see if the computers can play imitation game, which is Alan Turing test, technically Turing test. But I think the explanation for why ChatGPT cannot play tic-tac-toe or cabbage wolf goat is simple, because it's not trained to play tic-tac-toe. It's just trained to put words together to make meaningful sentences. It's not trained for reasoning. Do you agree? But you know that we discussed this, like, I think 6 years ago, about AlphaGo. So AlphaGo is a AI model that was trained to play Go, and Go is the most sophisticated game on a board. And I believe in 2016, and the DeepMind AlphaGo software AI model could beat the best Go player on the planet.
All right.
8 years ago, right? Because that AI model was trained to play game, but ChatGPT really wasn't trained to play game. And there's another thing here. So when you play tic-tac-toe with me, for example, or with a 6-year-old kid, during the playing, okay, I learn. During the playing with you, I learn from my mistakes because our brain get trained continuously. So when I play with you, you play with me. When I make a mistake, I learn from my mistake right away and don't make it the same mistake again after 1 minute. But when you play with ChatGPT, we don't train it, okay? This is the thing. The model is already trained. That's why it keeps making the same mistakes, because we don't retrain it. ChatGPT just have a reinforcement learning, which is active, and it's just designed to learn from us, from our feedback, to rearrange the sentence to make us happy, to make us satisfied. So if it makes a sentence for you, if you notice right away, there is a button for feedback. If you can provide feedback, and that's reinforcement learning. It's a very small reinforcement learning. It can rearrange the words to make us happy, but we don't really train it during the conversation. That's why it keeps making, if it's not trained to play tic-tac-toe, for example, it keeps making the same mistake on and on. It doesn't learn from us. If it makes a nonsense mistake, a simple mistake, it keeps doing that because we don't train it during the conversation. But human, when you play with me, when you play tic-tac-toe with me, my brain keeps learning from the mistakes simultaneously. That's why human doesn't make the same mistake again after 10 seconds. But ChatGPT, we don't train it, right?
Right, okay. So a couple of things. If you remember the part where I talked about Ev Fedorenko's work, she was fairly convincing that the ability to manipulate words, to create sentences, create coherent sounding sentences, is pretty much independent of the ability to think. And so ChatGPT, all the large language models have been trained to create coherent sentences. And so they're very good at stringing words together. But when they do that, even at the level of semantics, they're doing it at the word level. Now, if you remember, there was a diagram where there are words at the top and things at the bottom. And large language models are very good at moving words around and doing things that, seem like they're having a conversation, but they really do not have the ability to connect those words to things. Now, in some ways, they sort of sound like they do because they've seen so much stuff as part of their training that, they know words that refer to things in the world, but they just don't have the connection to the word, between the word and the thing. And so, as LeCun said, one of the things that we don't know how to do is to build a system which has that connection and where the system actually learns by its interaction with the world. We're not close. Well, I mean, if we could do that, that would be getting a lot closer to artificial general intelligence. But
Right.
we can't do that. We just don't know how to do that. And so what he's working on is something that's not a large language model that he hopes would be closer to a more general intelligence.
I agree with you, but the thing is that, Russ, I think, first of all, we don't know what's going on behind the I don't know, doors in OpenAI company or Google. Those their secret AI project, what are they about? But the thing is that what we know about language models, large language models, they are just trained based on text, of course. So that's I think the type of data that we provide to those models are different. That's why the understanding of the concepts are different. So when we say Apple, okay, ChatGPT is smart enough to understand the difference between Apple as a fruit and Apple company. This is what Transformer does, to find the difference, to understand the difference between Apple as a fruit and Apple company from the sentence, from the other words in the sentence. But of course, our brain over time, in the past, like 30, 40, 50, 60 years, we learned the word apple in many different situations and concepts. The smell of apple, the taste of apple, apple tree, the connection between Apple and Newton, the Apple company, the Apple, I don't know, many different things, all right? Not only based on text, based on smell of an apple, based on taste of an apple, picture of an apple, how an apple looks like on a tree. So our brain received a lot of data from many different situations, different types of data, not just text. That's why we will have a way better understanding of words. We can understand the concept of apple because our brain received more data, not because our brain is stronger. AI, artificial neural network, they use the same structure as our brain. So this is the AI scientists have done in the past 2 decades. They exactly try to mimic our brain. So they mimicked one neuron and then connected millions and billions of them together to create a neural network. So it is exactly like our brain. The only difference is that the data that they provide to train that neural network is different from the data that we receive from different sensors like eyes, ears, etc. But I think, again, AlphaGo is an example. You know that DeepMind developed a set of Atari games that they started from scratch. They learned only, they didn't provide the rules of playing game to that algorithm, to that AI. It just learned from playing. And they are really smart, and looks like those algorithms, for example, AlphaGo or other algorithms, they really do reasoning. So they think that if I make this move, then what will happen next? So it does make decision, it does decision making, it does, I don't know, kind of reasoning. But ChatGPT technically is designed to just make sentences. That's why. But
okay, so well, a couple of things again, though. Transformers are a very powerful mechanism. And I went over it relatively quickly, but you can use transformers to, as I said, predict the paths of hurricanes, which has nothing to do with sentences. So I don't know exactly what those things were trained on, but presumably not on words. And yet the transformer mechanism is powerful enough to relate influences from far away and from close by, and see what kind of patterns exist in the action in the input that they get, which is from the world. And so they do very well. It's do impressively well. So and as I said, they use the transformer mechanism to discover drugs. They use the transformer mechanism to discover new materials. It's quite something. So it's a very powerful mechanism.
Right. So transformers, we can apply them on any type of sequential data as long as it's a time series. And the difference between transformers and other like models like LSTM is that it can also capture and learn long-term patterns, very, very long-term patterns in the sentence. That's why it provides way better results compared to LSTM with lower computational complexity.
So one thing, let me just get this out before I forget it. One thing about AlphaGo is that someone discovered how to beat AlphaGo, even if you give it like 9 extra stones to start with, some ridiculous number. And there's some problem in the way it plays, that you give it this original setup, you give it its nine extra moves, 9 extra initial moves, and you can still beat it. So there's something very strange about that. And the person who discovered this is a Go player, but not a super expert Go player. He just happened to figure out how to do that.
So you mean it changed the rules of the game?
No, it didn't change the rules. But a stronger player gives the weaker player extra stones at the beginning of the game. And you put those extra stones around the board. And so the weaker player starts off with extra stones on the board.
Right.
And what this person discovered is you can give AlphaGo 9 extra stones, which is an extraordinarily large advantage, and still beat it, because there's some glitch in its way of playing that you can trick it into losing. Now, I don't have a reference to that, but I saw that not too long ago.
So can I share my screen? I want to show you a video. Can you see my screen?
Yeah.
So this is a video from DeepMind. I think it's from 9 years ago. So it is before this new revolution, AI revolution, before transformer thing. So it's I maybe we discussed this before, but this is Google DeepMind, how it learns to play Atari game. So this starts with one simple Atari game. The thing is that they did not provide domain knowledge. So they didn't tell the AI how to play. They didn't tell the AI the rules at all. So the only thing that was provided to the AI was the pixels of the screen. And the goal was to increase the score. So the AI starts, so this is what I show usually in my class. After 10 minutes of training, it starts from scratch. So you see that it plays awful. It doesn't know how to play. It's only after 10 minutes of training, okay? It really doesn't know how to play. So the goal is to eliminate that wall. After 2 hours of training, it plays like an expert, okay? But after 4 hours of training, the magic happens. It's like magic to me. It's really impressive. So it learns that by making a tunnel in the wall, look, achieves the best score. So it's kind of like reasoning, you know, it learns to, I don't know how we can explain that, but it learned that if it makes a hole in the wall, then the ball will go behind the ball will go behind the wall and it will get the most score. So it's really impressive. It's really impressive that it can really learn like a human to make decision, to do reasoning. And because it was designed to play games. And so it depends on the type of data that we provide to AI. It's not about how sophisticated or, well, because AI models that we have these days are like neural network, the structure and architecture of that is exactly like our brain. So technically everything our brain can do, AI models, artificial neural networks should do as well. So the difference is that this is the concern of like people like Jeff Hinton and other, like the godfather of AI, is that the problem is that we can, the computers, the AI models can learn many different things simultaneously, but we can copy that knowledge from one computer to another instantly. Okay, so when ChatGPT is a huge computer with a great knowledge in creating text, okay, we can easily copy that knowledge to another group of computers instantly, right? These are just some weights of a neural network that you should copy. But human cannot do that. So you cannot deliver the knowledge, your knowledge, to my brain in a second, but we can do it with computers, right? So the concern is that if only one of those computers in this AI world get smart enough to understand these things and to have self-awareness, okay, then that computer can copy its knowledge to thousands of computers and millions of computers in a second. And then we will have an army of smart AI models that each one of them is smarter than us, because we provided the whole knowledge on the planet, the whole data that we collected over millions of years. We provided all of that data to that AI model, and it learned from all of them. So that's why that computer is more knowledgeable than human. And it can create an army of itself in a second. So this is the concern of Jeff Hinton. That's why he has stepped down. And I understand. I understand this concern, honestly.
So in order to do that, you have to, you assume that you're starting with a computer that has all the knowledge, that we've ever created, and we don't know how to build that computer. Once we build that computer, you then do what you said, you make millions of copies of it, but we're nowhere near building that first computer.
I don't know, because the advancement that we had in AI in the past like 2-3 years was really impressive. And if we continue with this pace, with this speed, I think that general AI model is not that far. We don't know. Honestly,
I guess we'll see.
Nobody knows. We don't know. But anyways, Your talk was really impressive. I loved it.
Oh, thank you.
Very good, Raj. Yeah.
And it doesn't matter whether we agree on how close we are to general AI, whatever happens is going to happen anyway.
Yeah, but my point was that we should not underestimate AI. So ChatGPT made stupid mistakes because it was not trained to play.
Right. So
and it does not learn. It does not learn from conversation with us, right? Because training stage is another stage. It does not get trained when we have a conversation. Although we try to train it, we try to make it understand things, but it does not, because it's not training stage. It's just interfering stage. So
Okay, we have one question in the chat box.
oh, should I look there?
So basically, is there a structure in our brain that we cannot replicate in the weight of the neural network?
I would say you'd have to ask a biologist, a physiologist about that. I mean, I'm not convinced that neural nets can do everything brains can do, even though the architecture is similar. So, I mean, Mo is saying that they're, one-to-one correspondence, more or less. I don't know. There may be a lot of other stuff going on that we don't know about, but we don't know.
well, do you believe in soul?
No.
If you believe in soul, right, we cannot make that in artificial neural networks. But I personally think that other than that, if you don't believe in soul, I think everything that our brain can do, AI can do as well, as long as it's complex enough, as long as it's complex enough and trained enough. Okay, so I don't get surprised if the future AI models can have feeling and emotions, like they get angry, they get jealous, they will fall in love. Okay, it's not surprising if we create, and the problem is that we never know. Okay, you will never know if an AI model is jealous of you. Or
Well, that raises an interesting question. Let's say you wanted to train a neural net to get jealous. How would you do that? Now you can train it to act jealous, but if that's not the same as feeling jealous.
Maybe, well, we don't try to train a jealous AI, but over time, maybe we try to train an AI that can protect itself. Okay, an AI that can protect itself. For example, in autonomous driving car, we create cars that can protect themselves. Okay, the AI model can protect. So those AI models that want to protect themselves, after a while, if they have self-awareness, sometimes maybe they feel that other things can be a threat for them. And at that moment, they will feel anger or jealousy or this kind of thing. That's possible. That's possible.
Right, maybe they'll feel afraid.
Yeah. Well, these things, we have seen this in like Hollywood movies, sci-fi movies before, but we never know.
Well, David,
Yeah.
that's what Asimov's third law says, but how do we make that?
But it's just only in theory.
Yeah, it's very difficult to do Asimov's laws in practicality.
Yeah.
Now, I'm on the side of people who say we're not close to understanding what consciousness is like. So I don't think we're close to that. But then, you know, what do I know? I don't think we can build something that actually has true consciousness. And it's very difficult, you know, the imitation game is very difficult to distinguish in some cases between pretense and reality. So I don't know. Do we ever know what we've built?
The Hindu religion says we have a soul.
Okay.
Anyone has any other questions? Does anyone have any other questions?
So you can forward it to all those AI instructors that we have.
Thank you for coming, and
Thank you, sir.
It was,
those of you who
it was
stayed.
great. It was great talking to you, Ross, as always.
Yeah, you too.
Okay. See you.
Well, thank you very much, everyone.
Thank you very
It
much.
was a great talk. Thank you.
Thank you.
Thank
Have a
you.
good one. Thanks, Ross.
Thank you.
Have a good one.
My pleasure. Thank you. Bye.
Thank you.